Hello, dear student. Today we're going to be looking at an interesting topic on the concept representing organic compounds. There are four basic ways of representing the same molecules. Number one is by their molecular formula. Number two, structural formula. Number three, condensed structural formula, as well as the skeletal formula, which just shows a representation. An example is for the molecular formula, we have C3H8. That's just the formula representing such a compound. And also we have the structural formula, which means 3 carbon, represented as, you can see the carbon linkages from one carbon to the next carbon and also to the next carbon. And it has 8 hydrogen. You can count the number of hydrogen in this very compound and discover that it is 8 actually. Each of the carbon have 4 bonds each. Now, what about the condensed form? Now, for the condensed form, you could see where we have the structural formula, we have 3 carbons. It has 3, we have 1 carbon having the first carbon here having 3 hydrogen. And same thing, we have CH3. The next carbon have 2 hydrogen. That's why we have CH2 here. And the last carbon here have 3 hydrogen. That's why we have CH3. Now, what about the skeletal representation? It is just an indication. And you can see at this curve point here, it's showing that this position is a carbon position, meaning there is a carbon here. And this carbon here actually have 2 hydrogen, but it is not represented. That's why we call it skeletal formula. So the hydrogens are not displayed, but it means at this junction, there is a carbon here, and also at these other edges. You could see that here, it's a carbon. Here, it's a carbon, and at this end, there is a carbon, just as the way it is represented in this structural formula. All right, so, but one thing you must understand, and you must try to memorize as much as you can, is these prefixes. Now, the first prefix is a methane prefix. So we are not going to be calling the ANE, which is the last suffix. So we're just going to start with mate for 1, et for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and this for 10. Now, what about cyclic hydrocarbon? There are also some hydrocarbons that don't appear just in straight chain or branch chain, but in cyclic form. Now, carbon that forms a ring is represented under this class. Now, the general formula for cyclic alkane is CnH2n. Please take note of that. And example, we have cyclohexane. Hexane is 6, just as what we just saw from the previous slide. And having 6 carbon, meaning it has 12 hydrogens, and this is a typical representation of hexane. It can also be written in this form as well. Now you can see in this skeletal system, there are no hydrogens, but each of these edges that is curved is showing that these positions are carbon positions. And if carbons are represented here, that means all the carbons are going to be having 2 hydrogens to complete them being, to complete the 4 bonds that are supposed to be around them. Okay. Now, the difference between straight chain and branch chain hydrocarbons, let's look at this. Now, this is the first representation. We have 1, 2, 3, 4, 5 carbons in this very first compound. And this indicates that it is a straight chain because the carbons are arranged in one long chain. But for these other compounds, we call it branch chain because some carbons branch off from a main carbon chain. Now, for instance, I have this is the first carbon, there's a second carbon, there's a third carbon. If I will have to see it that way, then definitely this becomes a branch on it, and this becomes a branch on it. So in this scenario, you can see the difference between straight chain and branch chain. All right, so let's lay our emphasis a little bit upon branch chain. Naming side chains, the first thing you have to do based on the law we have known in the previous classes is that you must identify the parent chain, and the parent chain is the longest possible hydrocarbon chain. Number two, identify the substituents. Substituents are side chains or group. We call them branch most of the time. Now, the common side chain you could find commonly are the methyl family, which is CH3. If you look at this, it's actually a methane group, but because it has lost a hydrogen, it is the ANE is now replaced by YL, as well as you have the ethyl, the propyl, isopropyl. But also we have other possibilities where we can have halides group, such as the BR, which is for bromine, but now it's going to be called bromo. So wherever you see BR, you know, you're representing it as bromo, Cl for chloro, F for fluoro, and I for iodo. All right, so now let's look at structural representation to give us clearer example on it. This is a butane representation, but butane can be represented, we call them isomers anyway, but just to help us understand the formula structural representation of organic compounds, butane, this first compound or first representation of butane is in the straight form, the unbranched form. So we call this straight chain. Now, this other representation is called the branch because it has one branch here, the methyl branch. But okay, now this is called butane. But what is going to be the name for this other component now? You have a methyl group here, so we call it methyl. Now the parent chain is 1, 2, 3, which is propane. So the branch component here, the branch substituent is a methyl substituent, and that's why it's called methyl propane. Okay, now we have other complex examples. Now, in this illustration, just look at this expression. What could be the longest parent chain here? One can count and say, okay, we could have it this way. This is going to be 8, and that's an octa representation. But this octa representation, we started the numbering from the right-hand side, and this is 1, 2, 3, 4, 5, 6, 7, 8. That gives us the longest carbon chain. But now, along this, we now have a branch here. Now, if you can see this branch, it's a CH3 branch, which is a methyl branch. Now, and that is exactly what we've been talking about. Now, how are you going to call this now? Knowing fully where the parent chain is octane. Now, and the branch here is methyl. On what position is this branch found? Exactly, it's on carbon number 3. So this is how it's going to be. Now, this compound is going to be called 3 because it is the branch is found on carbon number 3, and the substituent, the name of that branch or that substituent is methyl. And the parent chain, which is the longest carbon to carbon chain, is octane. So that's how we come about the name. And remember that 3-methyl is a substituent. The parent chain is octane. Okay, now further examples. If in a case where you have same chain appears more than once, indicate how many times it appears by using prefixes. And when it appears once, it's mono, but when it is twice, we call it di. If it appears 3 times, you say tries, tri, and 4 times is tetra. Now, number all the carbon on the parent chain where groups are attached now and separate by commas. Now, look at this critical example. What could be the parent chain in this compound? It's clear. We have carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8. Why do we have to start numbering from the first carbon from the left? The reason is because the branches are closest to this left side of the chain. And so that's why we're numbering from that part of the chain. And so this is also an octane parent chain, but now we have 2 substituents. The first substituent is on carbon number 2, the second substituent on carbon number 3, And now there are two of them, so it's no longer going to be just methyl, it's going to be di, meaning that there are two substituents on this parent chain of octane. Now, if there are different groups attached, you have to come and ensure that alphabetically they are represented. Now, for instance, we have this. Now, just look at the structures. Now, what could be the parent chain in this? The parent chain is 7, which is heptane. 1, 2, 3, 4, 5, 6, 7. But now look at this. We have 3 different substituents on it. The first substituent is the methyl group on carbon number 2. The second substituent is the ethyl group. Remember, ethyl group is CH2CH3, meaning C2H5. Now, the second ethyl group, which is the third substituent, is on carbon number 4. Why are we numbering from here? As I told you earlier in the previous slide, is that the branches are closest to the right-hand side. So we need to start numbering from the right-hand side, not the left-hand side in this case. Now, if we need to count and name the structure properly, you can discover that methyl is found on carbon number 2 here, and ethyl, 2 ethyl, 1 on carbon number 3 and the other on carbon number 4. So what does the name look like? Now, this is the compound we have. Now, in this case, why is diethyl coming first before 2-methyl, while in the structure, methyl comes first? The reason is because we have to obey the rule of alphabetical precedence. Now, E comes before M. Ethyl starts with E. Methyl starts with an M. And so that's why we need to start numbering. We name this compound using alphabetical orders. Now, 3, remember you separate numbers to numbers with a comma, 4, meaning 3 on position 3, one of the ethyl on position 3 and the other on position 4. The di here means there are 2 of them, and ethyl means the substituent. The next, we have to now indicate the position of methyl. On position number 2, remember, hyphen, you separate alphabet from numbers using hyphen, and we'll do the same thing here, numbers to alphabet, hyphen as well. Now the substituent is a methyl group, and now the parent chain is heptane because there are 7 carbon as the parent carbon-to-carbon components. All right, so I'm going to give you something to practice. So you could just, during your leisure time, go through it for yourself. Just make yourself happy about it. Now, name these compounds. Now, look at this. We have, this is a complex compound. So what could be the longest chain? If I will have to start from this direction, I'll count. Now, remember I told you in the skeletal representation that wherever you find an edge, a curve, that means at that position, there is a carbon. So this is the first carbon, there's a second possible carbon, there's a third carbon, there's a fourth, fifth, sixth, 7, 8. But if we need to count from another direction, I think this should be the best because you start from here, you have 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon, 9 carbon. There is no other direction that could give you up to number 9. And number 9 is nonane. And so looking at this critically by indicating by this green denotation, what could be the branch on this? You see, we have 3 branches. Sure. Outside this green indication, there are 3 branches. The first one here is a methyl group, and we also have another methyl group, but here is not a methyl group because there is a curve here. That means there is a carbon here, and the carbon likely have 2 hydrogen, meaning this is an ethyl group. So how many branch substituent do we have? We have 3. We have 2 methyl substituent and 1 ethyl substituent. Now that's what I meant. So the parent chain is 9 carbon. 9 carbon means what? Nonane. And we have 2 methyl group, just as what I indicated here as well. And we have 1 ethyl group, exactly what I just explained here. Okay, now I'm back to cycloalkane with single substituent. There's possibility we could have cycloalkane that just have 1 substituent attached to it. This is an example. Now, how many carbon is here? Now, if I will ask you, how many edges are here? How many curves are here? You could discover that this You can count it 1, 2, 3, 4, 5. That are 5 possible carbon in this. And 5 means what? 5 means pentane. All right. So now it has a substituent attached to it, bromine. So what do you think could be the name for this? Simple. Since there are 5 carbon atoms, meaning it is pentane, the meaning that they are cyclic in nature, that means cyclo, pentane, cyclo, because it's cyclic. And now the substituent here is Br. We already said Br represents bromo. So what could be the name? Simple. The compound is bromo cyclopentane. Simple. Bromo for the substituent, cyclo representing the representation of the compound, pentane is the parent, the longest parent carbon representative. Okay. Notice a number is not required when there is only one substituent group. You don't need to number it and say 1 bromo, no, because it's only one substituent available. Okay, so we need to have a difference between cycloalkane with multiple substituents. For instance, now, this is a compound. Let's look at this. It has a numbering system. We have number 1, number 2, number 3, number 4, number 5, number 6. This is hexane, right? But it has 2 substituents. It has an ethyl substituent here, and it has a methyl substituent here. Guess you can see the difference. Now, also, this is also another similar structure with this, but now the numbering is different. Now, this is number 2, number 3, number 4, number 5, number 6. Yes. So now look at this 2. Which of this numbering is correct? And why do you think so? Yes. So at this point, where are we going to start numbering from? We accepted we start by weight. Ethyl is bigger than methyl. So ethyl is attached to this point, and that's why we're giving it number 1, because ethyl is bigger than methyl in terms of mass, molar mass. So, but why do we have to go this way? And why do we have to come this way? So which among these 2 structures is correct? That's the question. The name for this is 1-ethyl, 3-methyl, cyclohexane. 1-ethyl, meaning on carbon number 1, there's an ethyl group. Then we counted this way, 2, 3, we now made methyl. That means 3-methyl. Then because it's cyclo, we call it cyclo. How many carbon in this cyclo? 6, so it says hexane. Now, the name for this other compound, though they are the same, but the numbering makes them different. So in this case, we have number 1 here for ethyl, 1-ethyl, but now 5-methyl. So that means the numbering goes on the anti-clockwise direction. Now, when it is going anti-clockwise direction, number 1, 2, 3, 4, 5. So methyl group is on number 5. Methyl cyclohexane. So which of these 2 is correct? If I'm the one, I'm going to pick this. Yes, I would say that 1-ethyl, 3-methyl cyclohexane is correct because more of this branch is closest. The distance between the first branch and the second branch is closest when you're counting clockwise, but it is further when you're counting anti-clockwise. So this is the correct naming for this compound. 1-ethyl, 3-methyl cyclohexane. All right. Finally, what does this guy have to tell us? Well, he said we have to practice some few examples. Take note of it. I will be asking you out of these practices I'm giving to you. Number 1, look at the structure. What is the longest parent chain here? I could just say yes. 1, 2, 3, 4, 5, 6. That's hexane. And how many substituents does it have? It has just only 1. Yes, it has just 1. But I can decide to start the counting from here because this branch is closest 2, this carbon, I can say this is carbon 1, carbon 2, carbon 3. So methyl group is on carbon 3. So I'll say 3-methyl, right? 3-methyl because it's on carbon 3. Then the longest chain is hexane. 3-methyl hexane. Yes. So practice it yourself again. Now the second option is this. What could be the possible longest chain? There are different directions to come from. But like I told you, I can start from here. I would prefer starting from here. First carbon, absolutely. Second carbon, this. Third carbon, this. Fourth carbon is this. I won't go this way. I will go up. Fifth, sixth, seventh. That's heptane, right? So how many branches do I have? I have one branch here. I have two branch, and I have an ethyl branch over here. Remember, this is the first carbon, this is second, this is third. So I have 2, 3 dimethyl already. So ethyl group is on number what? 4. So remember our naming, we don't start with methyl, we start with ethyl based on alphabetical precedence. So this is 4 ethyl, right? 2, 3 dimethyl. Then the longest chain is 7. 1, 2, 3, 4, 5, 6, 7. Heptane. Practice it. I'll be asking you. All right, so the third one is simple. I will expect you to do it yourself. So get ready to give me the answer. I'm not going to tell you the answer for this. Thank you so much. All right, so on the final note, our friends just have something to tell us. And he said success is only for the brave. Keep doing what you're doing. Keep believing in yourself. Someday, very soon, you'll become successful. And we always celebrate you. Good luck. God bless you.